since we're doing two sections, 1.8 and 1.9, I can evaluate and estimate roots. So first we need to do some definitions. The first definition is a square root. And the square root of a number is one of its two equal factors. So I'm going to write that down. The square root of a number is one of its two equal factors. Factors means we're multiplying, so we need two numbers that are the same that multiply to be whatever is under the square root. Like the square root of 25 would be 5 because 5 times 5 is 25. I'm going to have you write underneath this the calculator button for this too. This button right here is the square root, so it's above the 7. So on my calculator, I'm going to put calc for calculator, it's just above the 7, there's a button that looks like this. The next definition is going to be the cube root. And the cube root of a number is one of its three equal factors. So this time it's like the cube root of 27 is 3 because 3 times 3 times 3 is 27. This one is a little bit more complicated on your calculator, so make sure you write this down. It's going to be, you're going to hit the 3 first. So your white button that has a 3 on it, that did not show up very well, or turn out very well. Looks like this, it has a 3. Then you're going to hit the second button next. And then you hit the button that looks like this, your exponent button, with the x root above it. When you hit second, that kind of activates what's above the button. So if you look at the calculator, if I wanted to do the cube root of 27, I would hit the 3 first, then second, and then this button to activate what's above it, the x root. Now I have the cube root. 27 is 3. Then we'll do some example problems. So for example 1, this says the square root of, let's do 81. So the square root of 81 means what times itself equals 81. There are actually two answers to the square root of 81. It could be 9 because 9 times 9 is 81, or it could be negative 9 because negative 9 times negative 9 is 81. This symbol means we only want the positive answer. So I'm only going to put a positive 9. If you didn't know that, you could use your calculator to do this button again. Square root of 81 is 9. If we see this symbol, if I see a plus and a minus outside my square root, like the plus or minus the square root of 49 is how we would read that, that means it wants the positive and the negative answer. So the square root of 49 is 7, because 7 times 7 is 49, so I would do plus or minus 7. This means plus or minus 7, that's how we would read it, but you write the plus and the minus on top of each other. For example 3, let's do the square root of 9/25. When you have a fraction, I would just do the square root of the top over the square root of the bottom. The square root of 9 is 3, because 3 times 3 is 9. The square root of 25 is 5, so I get 3/5. And then for example 4, what if I have the square root of negative, let's do negative 64. Let's try it on our calculator. The square root of negative 64, it says domain error. Why did it give us an error? There's nothing that I can multiply by itself to give me a negative 64. Positive 8 times positive 8 is positive 64. Negative 8 times negative 8 is also positive 64. So there's no real number that when multiplied by itself will give me a negative 64, so I'm going to put no real solution. Okay, we have just one more kind of square root problem, then we'll go on to cube roots. The only other kind of, two more, sorry I lied. Number 5. It'll be something like the square root of 2.25. The decimal, I would do the same thing. The square root of, whoops, clear, 2.25, going to be 1.5. Just type it into your calculator. Number 6 is going to be x squared equals, let's do 144. We need to solve this equation for x. When you solve equations, you always do the opposite of what's being done to the variable. So the opposite of squaring is taking the square root. So I'm going to take the square root of this side and this side. Whatever I do to one side, I have to do to the other. So now I have x by itself because the square root undoes the squaring. The square root of 144 is 12. Here's what's tricky about this kind of a problem is positive 12 times positive 12 will give me a positive 144. But what would happen if I also plugged in a negative 12 for x, and I did negative 12 times negative 12? That would also give me a positive 144. So for equations like this, I have to have positive and negative 12. Okay, let's do some cube root problems. 7, I'm going to do the cube root of negative 64. Okay, we couldn't have a negative under a square root. Let's see if we can have it under a cube root. Again, I'm going to do 3, and then second, and then this button with the root on top, and then negative 64. That gave me a negative 4. That does give me an answer. This one can have a negative inside because negative 4 times negative 4 times negative 4 is negative 64. For number 8, let's do x cubed equals negative, let's do 216. The opposite of cubing is taking the cube root. So I've undone the cubing with the cube root, so I just have x by itself. And the cube root of negative 216, if I type that in, I'm going to get, let me do 3, second, it gives me a negative 6. Okay, this one had 2 answers. I'm going to think about if this one should have 2 answers, and it shouldn't, because negative 6 times negative 6 times negative 6 is negative 216, but 6 times 6 times 6 is positive 216, so I can only have one answer on cube root equations. Alright, the only other thing we have left is estimating roots. So for estimating roots, we're going to estimate to the nearest integer. And integers are whole numbers. They can be positive or negative or 0, but they can't be fractions. So for example 9, if it says estimate to the nearest integer the square root of 50, 50 is pretty close to 49, and the square root of 49 is 7, so this is going to be approximately equal to 7. The squiggly equal sign means about equal to. For number 10, let's estimate the cube root of 120. I look for the closest perfect cube. So 125 is a perfect cube because 5 times 5 times 5 is 125. So it's pretty close to 125, so the cube root must be pretty close to 5.